Between July 1st and July 26th of this year, the Pacific Northwest Seismic Network located 36 earthquakes underneath Mount St. Helens. The largest was a magnitude 1.9, and the smallest was a magnitude minus 0.3. That's a negative magnitude. Hang on to that number because it turns out to be the most useful one I'll share with you in this whole video. A normal month at this volcano is about 22 located earthquakes. That's the long-term average USGS publishes for Mount St. Helens. So 36 in 26 days is up. Not dramatically, but up. Across those same 26 days, 4 other things didn't move at all. The ground didn't swell, the gas output didn't change. The alert level stayed on green, and the Cascades Volcano Observatory, which posts a news item every time something at one of these mountains is worth sharing, hasn't posted anything. So you've got a volcano that killed 57 people inside the lifetime of most people watching this, shaking a little more than usual, and the federal observatory that watches it saying nothing about it at all. Now, that gap is where every bad volcano video on the internet comes from, and here's what I'm going to put in it instead. The scientists who watch this mountain keep a published list of what they expect to see before Mount St. Helens erupts again. And they share 5 things, in roughly the order they expect them to happen. Not a feeling, it's a checklist with an instrument attached to every item. So what I'm going to do, I'm going to take you through all 5, and after each one, I'll tell you what that instrument is reading right now. And I'll give you the score up front, so you're not sitting here waiting for it. Today, the count is 0 out of those 5. None of them are present. The reason it's still worth your time is that 4 of those 5 things are the things that you can check yourself tonight for free, without me or anybody else needing to interpret them for you. And the 5th one is the reason 57 people died in 1980. Not because the mountain kept a secret, but because of something that nobody had ever watched a volcano do before. That's the back half of this video, and it's what's changed how every volcano in America is monitored today. Okay, so while we're here, one for the comments. Do you remember May 18th in 1980? And if you do remember it, tell me where you were and what you actually heard at the time. If you're like me and you weren't born yet, you can tell me what you were taught about it instead. I'd bet that those 2 groups of people are carrying completely different versions of this story around with them. One thing before the list, because it's what makes the list worth anything. Because of the eruptions in 1980 through 1986, and again in 2004 through 2008, Mount St. Helens has the best seismic monitoring network of any volcano in the Cascade Range. 2 full eruption sequences happened underneath modern instruments. We're not guessing at what this mountain does on its way up. We watched it do it twice. Okay, let's get into it. Sign number 1. The earthquakes move upward. Now, USGS sorts the shaking here by depth, and the depth is the part that carries the meaning. Earthquakes deeper than about 3 kilometers, roughly 2 miles, get read as new molten rock arriving into the system from below. Earthquakes shallower than about 2 kilometers, 1.25 miles or so, are the ones that typically come before a dome-building eruption, because that's magma stressing the rock immediately above it as it forces a path toward the crater floor. So the number carrying the most information isn't the count, it's the depth, and whether that depth is shrinking week over week. A swarm that parks at 5 kilometers, a bit over 3 miles, for a year is a volcano filling up. A swarm that walks from 5 kilometers up to 2, from 3 miles to 1.25 miles, is a volcano opening a door. So for today, the quakes are deep, and they're staying deep. There's no shallow seismicity at Mount St. Helens right now. So sign number 1 is not present yet. Sign number 2, the shaking changes its character. An ordinary earthquake is brittle rock snapping, sharp, abrupt, over. When fluid, magma or gas or superheated water, starts moving through a crack under pressure, the crack resonates instead, and the seismogram stops looking like a snap and starts looking like a note being held. Geologists call those long period events, and the sustained version is harmonic tremor. During the 2004 to 2008 eruption, this volcano produced something so regular it got named for the sound of it. Drumbeat earthquakes. Small, evenly spaced, metronomic, and they tracked the emergence of a lava spine at the surface almost step for step. That is what magma on the move looks like on a seismometer. Today, the located events are ordinary snapping rock. USGS has not reported long period events or tremors. Sign 2 is not present. And now sign number 3, the mountain changes its shape. This is the one 1980 taught the world, and I'll come back to it at the end because the numbers are hard to believe. The principle is simple. Magma takes up room. When it climbs into the shallow part of a volcano, it has to push the rock somewhere, and the rock goes outward and upward. USGS runs continuous GPS at St. Helens for exactly this reason. Ground inflation or uplift signals rising magma, in their words. Today, that instrument is flat. There's no inflation and no uplift happening. And this is the distinction I'd most like you to walk away with. Earthquakes with no deformation are a reservoir taking on volume. Earthquakes with deformation are that volume moving up. It's the same shaking but completely different story, and the difference is a line on a GPS chart. Sign number 3 is not present today. And sign number 4, the gas arrives. Magma carries dissolved gas, and as it rises, the pressure drops, and that gas comes out of solution. Carbon dioxide first, because it separates deep. Then sulfur dioxide as the magma gets closer to the surface. So a rising ratio of sulfur dioxide to carbon dioxide is a proximity signal. It's the volcano telling you how far the magma has come. And this isn't theoretical here. USGS says increased rates of sulfur dioxide, measured before several of the dome extrusions at this mountain, were signs that magma was moving more rapidly toward the crater vent. The gas told them before the rock did. For scale on what a loud volcano looks like on this instrument, in the year or so after the 1980 eruption, Mount St. Helens hit peak carbon dioxide emissions of over 22,000 tons a day. Today, the gas surveys read as background. Sign 4 is not present. Sign 5, steam. Before magma reaches the surface, it reaches the groundwater and the glacial ice sitting above it, and water flashing to steam inside a confined space is an explosion. These are phreatic eruptions, steam blasts. They throw old rock and ash without any new lava at all, which is why they sometimes get written off as minor, and writing them off is a mistake. A steam blast is the volcano telling you heat has arrived at a depth where it can reach water. It's the last cheap warning you get. There hasn't been one. Sign 5 is not present. That's the checklist, so deeper to shallower. Snaps to sustained notes. A shape that starts to swell, gas going up, steam at the surface, 0 out of 5. Which leaves the obvious question, and it's the right one to have. If none of the 5 are happening, why is it shaking at all? The word attached to that is recharge. It usually gets thrown around without anybody fully explaining what it means. Underneath Mount St. Helens, there's a magma reservoir sitting in the crust. Every so often, new molten rock arrives into it from deeper down. That new material adds volume and pressure to a system already sitting in stressed rock, and the rock responds the only way it can. It cracks. Small, deep, unremarkable cracks. Each one is an earthquake. Those earthquakes are the sound of the tank being topped up from underneath. Nothing about them says anything is leaving through the top. And this has been going on and off, for decades. USGS attributes the deep swarms between 1987 and 2004 to exactly this, 17 years of it. At the end of those 17 years, the mountain did erupt in 2004, and it spent 4 years building a lava dome without killing anybody. Then it happened again. In March 2016, a swarm started at depths between 2 and 7 kilometers. Call it 1.25 miles to 4.5 miles. Over the first 8 weeks, the Pacific Northwest Seismic Network located more than 130 earthquakes. Most were magnitude 0.5 or smaller. The largest reached 1.3. The rate climbed to nearly 40 located events a week. 40 a week. That's roughly double what this mountain is doing right now, and USGS was direct about it at the time. The gases weren't anomalous, ground inflation hadn't increased, and there was no shallow seismicity, so there was no sign of an imminent eruption. They also noted the pattern looked like the swarms of 2013 and 2014, which had gone nowhere either. Then, February 2024, around 350 earthquakes in a few months, most below magnitude 1, median depth about 3.5 miles below sea level. Weston Thelen, a research seismologist at the Cascades Volcano Observatory, described the volcano as recharging and put it plainly. Thus far, he said, we haven't seen a change in the shape of the volcano, either inflating or deflating, and we haven't seen any changes in gas output. He also said that when this mountain does go, the most likely eruption is the kind that just builds a dome. So count those, 2013, 2014, 2016, and 2024, and now a modest uptick from July 2026. That's the 5th time in 13 years this mountain has done a version of exactly what it's doing today, and on the previous 4 occasions, the answer came back the same. USGS puts it in one sentence that I think is the single most useful line in this whole subject. High rates of seismicity, interpreted as recharge, have been observed in the past at Mount St. Helens and other volcanoes, and can continue for many years without an eruption happening. Now I want to deal with the accusation side, because if you've searched this in the last week, you've run into it. The claim is that the agencies are hiding earthquakes. The real count is far higher than the published catalog, and somebody's sitting on those numbers. I want to take that seriously for a second, because underneath it there's a fair instinct. People are right to ask who checks the checkers. So here's the actual answer. The catalog holds every earthquake that could be located, which is a smaller set than every earthquake that happened. Locating an earthquake requires it to be recorded clearly on several stations at once, because you find the source by comparing arrival times across the network. A tremor so small that only one seismometer registers can't be located. There's no arithmetic that gets you a position from a single point. So it stays out of the located catalog, and PNSN and USGS have said so publicly, over and over for years. That limit is a detection floor, published as a detection floor, sitting underneath the catalog rather than over the top of it. And this is where that strange number from the opening comes back. Let me just show you because it's quicker than me describing it. What you're looking at is the Pacific Northwest Seismic Network's public catalog for Mount St. Helens. Anyone can open this. No account, no fee, no records request. I'm going to sort by magnitude, smallest first, and there it is at the bottom of the July list, minus 0.3. An earthquake so small it releases less energy than a heavy door slamming, sitting on a public web page with a timestamp and a depth attached to it. If somebody's suppressing small earthquakes at Mount St. Helens, they're doing a spectacularly poor job, because they published one that barely exists. While we're on the public pages, it's the alert level. 2 words, and they are the 2 ladders running side by side that people mix up constantly. The first ladder is written for people on the ground. Normal means the volcano isn't erupting. Advisory means elevated activity that could escalate. Watch means an eruption is likely, or one is already happening with limited hazards. Warning means a hazardous eruption is imminent or underway. The second ladder is the aviation color code, and it's about ash reaching aircraft, not danger on the ground. And this is the page that answers it, the USGS status page for Mount St. Helens. Alert level, normal. Aviation color code, green. That's what it says as I'm recording this, and it said the same thing every day of this swarm. So the question worth keeping in your pocket is one line. Has USGS moved this volcano off the bottom rung? Today, no. Now the 1980 sequence, because this mountain has already run the entire checklist in public. That timeline is the best calibration you'll ever get for this subject. I should tell you why I care about this one. I lived in the Pacific Northwest from about 8 years old to 12, and right around the Vancouver area. Mount St. Helens came up constantly. The adults in my life talked about it the same way people talk about a war that they lived through. And I remember there was a question that stuck with me, and it's a reason that I made this video today. How does anybody know a mountain can sit there for a century doing nothing, and then one morning it erupts? What could possibly tell you that it would happen on a certain day or a different one? Here's what they looked at. On March 16, 1980, a series of small earthquakes began under Mount St. Helens. Sign 1, opening. 11 days later, on March 27th, after hundreds more earthquakes, the volcano erupted for the first time in over a century. It was a steam blast, and arriving 2 months before anybody died. Then, the north flank started to move. Magma had intruded into the side of the mountain rather than the top, and it pushed a section of the north face roughly a mile across outward at about 2 meters a day. 2 meters. 6.5 feet every day. For weeks. By May 17th, that bulge had moved about 140 meters. 450 feet. Sit with that pace for a second because it's easy to skim. A piece of a mountain a mile wide moved 450 feet sideways in daylight while people photographed it. At 8:32 in the morning on May 18th, a magnitude 5.1 earthquake shook the volcano and the bulge let go. The entire north flank slid off in the largest landslide in recorded history, about 2.5 cubic kilometers of mountain, roughly 0.6 of a cubic mile. Removing that mass uncorked the pressurized system underneath it, and the eruption came out sideways instead of upward. 600 square kilometers were devastated, 230 square miles. Within about 6 miles of the summit, almost no trees were left standing. Snow and ice and entire glaciers melted and became lahars, volcanic mudflows, that ran down the Toutle River, destroyed 47 bridges and 185 miles of highway, took out more than 200 homes, and reached the Columbia River nearly 50 miles away. The summit had been 9,677 feet. Afterwards, 8,363. The mountain lost 1,314 feet of itself in a single morning. 57 people died. One of them was David Johnston, a USGS volcanologist at an observation post north of the mountain when the flank failed. His last transmission was Vancouver. Vancouver, this is it. The observatory that monitors these volcanoes today carries his name. Now I want you to read that timeline back against the checklist. March 16th, earthquakes. March 27th, steam. April and May, 450 feet of deformation. And May 18th, the eruption. 2 months of escalating, measurable, and visible from a road. And this is the part the scary version leaves out, and it matters more than anything else I've said. Mount St. Helens did not erupt without warning in 1980. It gave 2 months of warning in every category on that list, and the area was closed and most people were kept out. The 57 deaths happened because the blast went sideways and traveled far beyond what the hazard zone anticipated, and nobody had watched a volcano do that at that scale before. 1980 was a failure to predict the direction of a blast. The volcano itself had been noticed for 2 months. Every piece of monitoring hardware on that mountain today exists because of those 2 months. So set July 2026 against that. Nothing in it matches. I'd rather be super precise than reassuring for you, so here's the precise version. The alert level is at normal and the aviation color code is green. The seismicity is a little above the long-term average and well inside the range that this volcano has produced repeatedly without erupting, 4 separate times in the last 13 years. There's no deformation, no gas anomaly, and no shallow seismicity, which are 3 of the 5 things that you would need before this conversation changed. Now what I won't soften is the other half. Mount St. Helens is an active volcano that has erupted twice in the last 50 years and will erupt again. In 2018, USGS scored every volcano in the country on a 24-factor threat matrix, and this one came second at 235. Mount Rainier placed third at 203. Yellowstone placed 21st at 115. USGS also calls St. Helens the most likely of the volcanoes in the lower 48 states to erupt in the future. Recharge is real. It's been going on for decades, and the reservoir is being filled. Both of those things are true at once, and holding both is the whole skill we need to have. A volcano that will erupt someday and isn't erupting now is the normal condition of a volcano. It's the condition of dozens of mountains across the world tonight. Now the practical part for you, and I'll keep that short. If you live in the Toutle or Cowlitz valleys, or anywhere on the drainages coming off this mountain, the useful thing you can do this week takes about 15 minutes. Find out whether your address sits in a mudflow hazard zone. Washington's Department of Natural Resources and USGS both publish the maps, free, and this is what one looks like. That's the Toutle Valley running west off the mountain, and those shaded channels are the ground the mud uses. If your street is inside the shading, you want to know that today, rather than at 2 in the morning. I'll link the maps below. Then work out which way is uphill and away from the river, and learn it well enough that you wouldn't have to think about it. Mud flows are the hazard that reaches furthest from this mountain and moves fastest when it gets there. And the geography you already know is the geography that saves your family. And for everybody else, here's how to stop needing videos like this one. USGS publishes the alert level for every American volcano, updated continuously on their own site. PNSN publishes every located earthquake at Mount St. Helens with its magnitude, depth, and time, free, no account needed. Between those 2 pages, you can answer the question yourself in about 40 seconds. If a thumbnail tells you a mountain is about to blow and the alert level says green, the thumbnail is selling you something. I put together an emergency preparedness guide because I got tired of describing hazards to people without handing them anything to do about it. Water, food, medication you might need are documents, and one plan the whole household actually knows. It's an afternoon of your work, and it covers a lot more than just volcanoes. The link's below if it would be useful. If this is the kind of thing you want more of, subscribing to Critical Latitude is what keeps it coming. What you get from me is the alert level reported exactly as it reads, green or otherwise, the sources on the screen, and a correction posted whenever I get something wrong. One last thought to share. For 46 years, Mount St. Helens has been the most closely watched volcano in the Cascade Range. And in that time, it's taught us that the warning signs arrive in sequence, and that the sequence stays boring for a very long time before it stops being boring. 36 small earthquakes in July is what the boring part looks like. So were the 130 in 2016 and the 350 in 2024. The mountain kept no secret back in 1980. It gave up everything it had for 2 months, and the people watching it most closely still couldn't picture the shape that the thing would take. And that's the real lesson here, and it's a lesson about us, not about the rock. What we're watching for is written down and published. What we can't do yet is imagine every way the ground is willing to surprise us, which is exactly why you check the alert level yourself and why you learn your route before you need it. If this was useful for you, the like button pushes it toward the people living in those valleys, and that's who I'd like it most to reach. Then go and find your 2 pages, USGS and PNSN, and bookmark them tonight. Take care of yourselves and stay safe.